Okay, so this question, example 2, I skipped example 1, by the way, just so you know, if you're wondering why we're starting with example 2. In this question, we've got a 2 kilogram bowling ball rolling towards a 3 kilogram bowling ball. This 3 kilogram bowling ball is stationary. The 2 kilogram bowling ball is moving at 5 meters per second north. And here's my little northeast, southwest. Why am I bowling one ball towards another? I don't know. But anyways, this ball is going to hit this ball, and if I can just put a little dotted line here just to show this is the direction, the original direction of motion if there was no collision would be to continue this way. After the collision though, this 2 kilogram ball is traveling north 25 east. So that's somewhere over here. Let's put 25 degrees there. That is this guy. Let's put the open circle. So that's this ball. This is V1 primed. So V1 primed, it goes off this way. The question is, what's the final velocity of this ball? What does this ball do after the collision? And before we do any work, if we just kind of think this through, we know that, let's say before the collision, if I cover this part up, before the collision, this guy is in motion, this guy is at rest. This one here is moving only north. This guy has no motion. So the combined total momentum before the collision is only north. Because momentum is conserved, that means after the collision, the combined momentum also has to only be north. If I look at this guy though, this guy's got a north component as well as an east component. We can't have that east component, right? We said before the collision, it's only got a north component, which means this ball here must have some kind of a west component in order to cancel out that east component. So this guy here must be going somewhere over this way. So if this is V2, this would be V2 primed, kind of going off this way. What we're going to do with these questions, we're going to break both of those up into their components. Okay, so let's start with V1. If I redraw that triangle, we're going to have it going this way and this way. So V1 primed, this is 25 degrees. We want to solve for what's V1, whoops, this is a Y, V1 Y primed and V1 X primed. We can solve for both of those. This side of the triangle is 2.7. I didn't write that. So 2.7 meters per second. That's this guy, 2.7 meters per second. Okay, so same triangles. This then would be 2.7 times the sine of 25. And this one over here, this guy here, would be V1Y primed, would be 2.7 times the sine, times the cosine, 25. Okay, so if I kind of break that up, this is the 2 kilogram ball, okay, that we're looking at here, this guy. We could kind of mention, let's see right here, we could kind of say right here, the 2 kilogram ball, before the collision, let's break that into components as well. V1x, V1y has no x component, right? It's only going north. No x, no y component. Sorry, no x component. It does have a y component. The y component is this 5 meters per second. That's straight north. After the collision, we've got these numbers. Okay, so V1x primed and V1y primed. And after that, let's see, we've got 2.7 sine 25 is this number. 1.14 meters per second, that's east. And V1y primed, the cosine one, that's 2.45. And that is north. Okay, so we've got those guys. We also want to do the same stuff for the 3 kilogram ball. The 3 kilogram ball before the collision isn't even moving. But after the collision must be going, I don't know, something like this anyways. Let's draw it. We don't really know what these numbers are, but and I'm kind of whoops, I can't talk and write at the same time. I am kind of assuming with my argument that it's going this way. even if we didn't realize it was going to go this way, when we go ahead and sub some numbers into our equations, we'll figure out what these components are. Okay, so what we're looking for is, what's this x component? What's this y component? Okay, so that's a question mark. That's a question mark. I don't know this angle. I'm going to find all that stuff out. I'm going to find those components. Once I know those, I can find this angle and I can find out this side. But just to kind of keep with this pattern, let's look at the 3 kilogram ball, again down here. And we are going to look at before the collision, so V2x, V2y. Both of those are 0. This guy's at rest. Then we're going to look at V2x primed, this guy, and V2y primed. I don't know either of those. That's what I'm trying to find out. Okay, so if I do that, let's move this up a little. I'm going to start off in the x direction. And I'm going to say conservation of momentum, so P equals P primed, all in the x direction here. We're going to say M1V1x plus M2V2x, M1V1x primed, M2V2x primed. What we're going to do now is just kind of sub in all of our numbers. Okay, so mass 1, 2 kilograms. V1x though is 0. That guy's gone. Mass 2 is 3 kilograms, but V2x also 0. That guy's gone. So our left-hand side here is 0. That's not always going to happen, but happens in this case. M1, again, we said was 2 kilograms. V1x primed is this number right here. 1.14. Yeah, we should be good. Let's call east our positive direction. We'll call north our positive direction, just to get those in. Okay, so that guy's going in as a positive. These are vectors. We do have to consider positive and negative directions. V2x primed, I don't know what that is. That's what I'm looking for. That's the only unknown there. If I rearrange this, V2x primed, let's see, we get, actually we get a negative, okay, so negative 0.7607 meters per second in my positive direction east. That negative indicates it's actually going west. Okay, 0.7607 meters per second, that's west. Okay, so this is not my answer, but I need this number. That is this component or this component right here. So during this collision, the 2 kilogram ball goes off kind of in the east direction. That must mean that the 3 kilogram ball goes off in the west direction, as expected. Let's also look here in the y direction. Let's split this up a little. Let's look in the y direction as well. We're doing the exact same thing. Py equals Py primed. Again, those things are vectors. We're breaking everything up into components. When I look at this, again, mass 1 is 2 kilograms, V1y is 5, that's north. I said north was the positive direction. V2, remember this guy is 0. He has no components right here. V2y, just 0. We could just cross it off. Mass 1, again, 2 kilograms. V1y primed, here it is, 2.45. And mass 2 is 3, and this guy I don't know. We're going to go ahead and solve for that. Let's see. If I rearrange a little bit, I had 5.1 equals 3 V2y prime, just to show a little math here. I'm multiplying those, multiply those, take this over. We get this 5.1 V2y primed, 1.7 meters per second north. Again, not my final answer. But those components are those components right there. Using that, I want to find this and I want to find that guy. Okay, so we're looking at this triangle here, but what we're going to say then is V2 primed. Just using Pythagoras, we're going to say it's this squared plus this squared. V2 primed, we work that out and it's approximately 1.9 meters per second. We also need that angle, as always. We've done these kind of things many times. Tan theta, opposite over adjacent, so this 7607 divided by the y component over 1.7, and that theta is about 24 degrees. So our answer, this V2 primed, am I still on the screen? Yep. V2 primed then is approximately 1.9 meters per second. This is north, 24 degrees west. Now I can stick a vector sign on it. And let me just make sure I answered the question. What's the final velocity? Yep, this is the final velocity of that bowling ball.